Okay, so we need our first number. Now, the thing is, our first term in here is actually not a sub 1, it's a sub negative 1. This starts at a negative 1, so I need to plug negative 1 in and see what that comes out for our top term. So that'd be a sub negative 1. I'm plugging a negative 1 in, which means I need to remember what happens when I have a negative exponent. Because we'd have negative 1/2 to the negative 1 minus 1, which equals 3 times 1/2 to the negative 2. Who remembers what to do? It seems like a few of us got it right, so some of us should know. What happens when I have a negative exponent? What happens when I have a negative exponent, Krupa? You flip the fraction. That's all that negative does, is it tells you to flip the fraction. So this is 3 1/2 to the negative 2, which we can rewrite as 3 to the 2 over 1 squared. So I get rid of that negative by flipping the fraction. Well, that's 3 times 4, which equals 12. That gives us everything we need for our equation, because we're going to put 12 on top. On the bottom, we'll have 1 minus our common ratio is 1/2. I got that 1/2 because it's the base of our exponent, of our exponential equation. So it's 1 minus 1/2. 1 minus 1/2 is 1/2. 12 divided by 1/2. Keep change flip. That's 12 times 2. We should come up with 24. The correct answer would be B, 24. Well,
how come you didn't put like n equals negative 1? Because like all the other ones have like a something equals, but you just put negative 1. Like what's the difference?
Where did I put negative 1? I'm sorry.
At the bottom of the thing. Like,
Here?
Yeah. No. Like the original problem.
Oh.
The original problem. The E thing? Yeah.
Oh, why did I put negative 1 there?
Instead of like n equals.
Because I can put any number I want there. You have to look at what number I put there.
Well, like what does it mean?
It means that the very first number you're going to plug in is negative 1. It's your lower limit. That's all it means, is what is the first number you'd plug in into this sequence.
Okay, so it's the same as like n equals negative 1.
It is the same thing as n equals negative 1, correct. So that is plugging in n equals negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually we either start at 1 or 0, but there's no rule. You can start wherever you wanted to. I could have put a 100 here. So that means the first number you'd plug in would be 100. So this is just me picking it. You will never pick that when you're right, because at times you have to write your own summation formula. At those point, you're always going to start yours at 1. But I can start anywhere I want, because I'm special. Okay? Why I might pick a different thing, Will? Let me just do an example. Let's say I'm doing, let's say my sequence is 89, 90, 100, not 100, let's go 91. And it just follows that pattern, right? So picture that, and I want to have a sum. So maybe I want to have plus between each of those. Well, my summation formula, I don't know where I keep saying formation. We could just have the sum of n, where n starts at 89 and goes forever. Because then I don't have to tweak this at all. I can just go, okay, plug in 89, then 90, then 91, then 92 to infinity. So then I don't have to change this formula at all, and it matches this sequence, 89 plus 90. So that's why I'd pick something different. Okay? All right, other questions on the bell work? Okay, then questions on the homework. Yeah. 19, yeah. Bless you. What is 19? 19 has computer password. How many different 3-letter computer passwords are available? If any letter can be used, but repetition can be used, but repetition of the letters is not allowed. So we have a computer password that uses just 3 letters. So one way we could do that is, for the first letter, we have 26 letters I can choose from, A through Z. Well, after I use up a letter, I can't use it anymore, so then I would only have 25 left. Well, after I use 25, I have one less, and I have 24 letters to do that combination. A slightly easier way, especially if you know how to use your calculator on this, is basically it's a permutation because order matters. And I start with 26 letters, and I am going to choose 3 of them. So I have 26, pick 3 of them, and you're going to find that this is both will come out with the same answer. And that's what permutations are. Permutations are this pattern of 26 factorial, stop at some point. So look at how this is written. It basically says this is 26 factorial, stop at 3 of them. 1, 2, 3, that's where this formula would have you stop. In other words, if you were doing the work, it'd be 26 factorial divided by 23 factorial. Well, that means stop at 23, get rid of it. Oh, that's just 26 times 25 times 24. So most permutation problems you can either think of as this or just use the equation. They both kind of mean the same thing. 26 factorial, stop at 3 digits. Oh, 24. That's my last one. Okay? Cool. Other questions? Yeah. Yeah, is that the ghost one? Okay, so drawing the ghost one, say it's 1 o'clock. I have 3 ghosts that can visit me, I guess. We can have a past ghost. We can have a present ghost. And we can have a future ghost. Now, we can't get visited by the past ghost 3 times in a row. They only can visit us once. So as soon as the past visits me, it can't visit me again. So let's go down the past route. So the past route goes into, after the past visits me, either the present or the future can visit me. Well, let's go down this route. Okay, the past visited me, the present visited me. That means the past and present can't visit me again. That only gives me 1 ghost left, and that would be my future ghost. If I went past future, then it would have to be present. So this is a combination where all 3 visit me, where the present comes first. The bottom one is my next one. So that gives me 2 options if the past visits me first. If the present does, once again, the present can't visit me again, so either the past or the future visits me, and each of those results in, if it goes present, past, it must be future. If it's present, future, it must be past. And for our final one, well, we just have past and present left. If it goes future, past, it has to be present. If it's future, present, it has to be past. And that will give me my 6 combinations. An easier way to look at this one, maybe the tree diagram isn't the easiest to picture. Maybe an easier way to do this is strictly do the math. And that is at 1 o'clock, 3 ghosts can visit me. At 2 o'clock, there's only 2 ghosts left because 1 visited me and it's gone. At 3 o'clock, there's only 1 ghost left. That equals 6. Maybe a little easier to think about that it's 3, 2, 1 left over. But does that drawing make sense then? Cool. Other questions? Yeah, go on. 14. Ooh, 14 is a good one to talk about. Everyone pay attention to this because I'm not going to do the equation. I will do the equation, but I want you to think about it first. Let's say I have all you guys in the room, and I'm going to pick 0 of you to get a $100 bill. How many ways are there to give you guys a $100 bill? There's 1 way. I just don't give you a $100 bill. That's the only way I can distribute no money to you guys, is I don't distribute it. So what this is saying is I have 99 of something, and I want to pick 0 of them. There's 1 way to pick 0 items, and that is to not pick any items. So 99 pick 0, 1,000 pick 0, 1,000,000 pick 0 should all result in 1. And if you forget that idea, the equation still works, because the equation is 99 factorial over 99 minus 0 factorial. Well, that just equals 99 factorial divided by 99 factorial. That just turns to 1. So either you think through it, or you just actually do the math, and it should result in 1. All right, other questions? Okay, then we'll go to today. On Friday, I said start thinking about when order matters and when order doesn't matter. Because today we're going to talk about combinations. Combination and permutations are the same idea. They are ways to calculate the number of possible arrangements. I give you 100 items, you pick 50 of them out. They're both that style. However, for permutation, you're only going to use the permutation formula when order matters. So when does order matter? So these are questions like lottery. You have a first, second, and third prize. I pick 3 people to get a first prize, a second prize, and a third prize. You care which one you get picked as. I'd be pretty mad if I got picked first place, but I get the third place prize. I'd be angry about that. That means order matters. For combinations, order does not matter. Order does not matter. When you decide what you're putting in a smoothie, maybe you have 10 fruits in front of you and you only can pick 4 to fit in the blender. It doesn't matter what order you pick the 4. And if I pick strawberry, apple, banana, kale, it doesn't matter if I pick kale first, as long as kale was selected and got thrown into my smoothie. Order didn't matter as long as all 4 of those got picked. So that's the difference between permutation and combination. I always bring up this fact. At a locker, at your combination lock, does it matter what order you put your numbers in? It doesn't? Oh, you guys have weird lockers here. Yeah, your locker, if you go to your locker, say your combination is 22, 14, 11, you can't put an 11 first and then 22, and it's like, close enough. You have to put it in order. So your combination lock is misnamed. It actually should be called a permutation lock because order matters. So combination actually should be called a permutation in that sense. All right, so big chart here. First of all, permutation, you're going to ask yourself, order, it matters. Order matters. Maybe you have 10 friends and you want to rank them from first to fourth. You're going to pick 4 of your friends out and you rank them first to eighth. It's kind of mean, but you rank your friends first through fourth. That would be a permutation. I'm ranking something first through fourth. Combination order does not matter. Same situation. You have 10 friends. You're going to pick 4 of them to go to the mall with you tonight. Order didn't matter as long as I picked those 4. I didn't care if I got picked first, second, third, or fourth. I'm going to the mall with you. Order did not matter as long as I was one of those 4 people. If I'm ranking, it matters. I want to be first. Going to the mall, as long as I'm going to the mall, order didn't matter. All right, the notation for permutation. We did this on Friday. That is, we do a cap P. And that's going to be followed by the total number in the group. And then R is me selecting some. So 10 friends, and that R would be 4. I'm ranking my top 4 friends. Another way to write this is N big P R. That's another way to write it. We'll typically stick with this one. Your calculator actually has this one if you can find that button in your calculator a lot of times. But this is the one we're going to use in class. Combination actually has 3 of them, and we'll use 2 of them in this class. So the first one is, it's just like permutation where it's big C, followed by how many I'm choosing from and how many I'm actually choosing. Or, just like the permutation one, we can put a big C And we can put an n to the left of it and an r to the right of it. Our final one, and we'll use this one tomorrow, we just actually put our n over r, and we put them in parentheses. That stands for combination. And we'll use that tomorrow. We usually use this to write formulas from. All right, the formula for permutation. We had the same one we had on Friday. That is n factorial over n minus r factorial. Combination is going to have the exact same formula with this one small change. So it's going to start out the exact same way. We're going to go n factorial over n minus 1 factorial. So that's all the same. Not n minus 1, I'm sorry. N minus r factorial. All right, we have a small change between permutation and combination. I just want you to kind of holistically think about which one should have more options and which one should have less options. So permutation order makes a difference. If I have U4 right here, and I rank you guys from first through fourth, for whatever reason, I'm ranking all four of you. Well, if I say it goes Thomas, Abraham, Adrian, and I go Krupa, that's different than me starting with Krupa, Adrian, Abraham, Thomas. Those will be two different choices. For a combination, order doesn't matter. No matter which number, no matter which name I say, that all counts as one. So Thomas, Abraham, Adrian, Krupa is the exact same thing as Krupa, Adrian, Abraham, Thomas. Those would be the exact same group. So that means our combination should have less choices in it. Because it doesn't matter, there's no ranking system. If I pick you 4, I'm not going to then rank you. I just pick you 4 into one group and throw you out the door. So your combination is going to have less numbers total. So we're going to multiply the denominator by r to get rid of all of the ordered ones. Basically saying, I'm just going to take you 4 and throw you out the door. I'm not ranking you guys. That's what that r is going to do. It's going to get rid of all the ones where you got ranked. So that r factorial will get rid of your ranking. So permutation and combination are the exact same formula, except combination has less results. So we're going to divide by r factorial. All right, an example. Solve using either permutation or combination. Okay, so once again, combination order does not matter. Permutation order does matter. So we have a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from 8 people on the board of supervisors? So if I say we're just forming a committee, and I don't list any kind of priority in it, I don't say we have a president, vice president, secretary, you can assume that means that you just have committee member number 1, committee member number 2, committee member number 3. It doesn't matter which one you're in the committee. I'm just picking 3 people, just grabbing you and saying you're in this committee. Order does not matter. Order would not matter. You're either in the committee or you're not in the committee. There is no ranking after you're in the committee. So does order matter? No. That means we're going to use a combination. With combination, we're going to go, okay, our n equals, we start with 8 people, and we need to pick 3 people. So we're going to go, okay, combination, 8, choose 3. So our equation is going to be 8 factorial over 8 minus 3 factorial times 3 factorial. I will note that there'll be a section in the homework, or the test, I should say, on Thursday that will say you can't use any calculators. This is one of the problems that could be in a no calculator section because you do not need a calculator to solve this. What you should do, if you don't need to use a calculator, start getting rid of some numbers. So we're going to go, okay, that's 8 times 7 times 6 times 5, and you should stop at 5. because I'm picturing, okay, it's 8765 factorial. That'll be all over 8 minus 3 is 5 factorial. 3 factorial is 3 times 2 times 1. So I can cross out those 5 factorials. On top of crossing out those 5 factorials, 3 times 2 is 6. So I can go, okay, 3 times 2 is 6. I could eliminate this 6 up here as well. Which means I absolutely did not need a calculator. I just need to do 8 times 7, which equals 56. So make sure you're able to cross some things out. We'll talk about a problem that you can't cross stuff out, and I'll show you what to do on your calculator. So if you have your calculator, you might as well get it out, because we'll kind of do ones that we can use our calculator. Our next one's kind of the most complicated one. It sounds easy. If I say order matters or doesn't matter, it sounds like it's just cut black or white. There are some gray area problems, and this is one of those gray area problems. We have 12 students help with a project. The director needs 3 telephone solicitors. He needs 4 door-to-door solicitors, and he needs 5 magicians. So we're breaking 12 people up into 3 phone solicitors, 4 door-to-doors, and 5 magicians. In how many ways can these jobs be assigned? Does order matter? Will?
Doesn't it? Because like once you get the right amount of like each thing, then you can't fill that thing up anymore.
Then you can't fill that thing up, right?
Like you, yeah.
I gotcha. So if you pick, so order matters. If I'm one of those 3 solicitors, I can't get picked for the other ones. So it feels like it matters. Who can argue it doesn't matter? Who can argue that order doesn't matter? Whether you believe it or not, who thinks they could argue that order doesn't matter in this one? Yeah, no, go.
I'm probably wrong.
That's
But I mean, aren't you just being assigned to a job, not specifically the order?
correct. So Nogel's counter-argument to that is, if I get picked to be a telephone solicitor, I'm not 1, 2, 3. I'm not getting ranked within those jobs. So that's why this is kind of a gray problem. We're going to go with Nogel's first. We're going to say, okay, if I get picked to be a phone, order doesn't matter. So we're going to say order doesn't matter. And then after I do some work, we'll talk about when the order does matter. So this is one of those gray areas, but we're going to start off with order does not matter. But Will, you're 100% correct. We still have to account for you getting picked in there and you can't go anywhere else. So we're going to say, does order matter? We're going to say a very soft no. We'll put a question mark after it because it's kind of a no-yes situation. But we're going to treat it as if order doesn't matter. It'll make your life easier. So we're going to use combination. Okay, let's talk about the phones. For phones, we have, 12 students to choose from? So we're going to go n equals 12. And I am choosing 3 people. So that's going to give me a formula. Combination 12, choose 3. Then we're going to get to the door people. Ugh, look at it work. Do I still have 12 people to choose from? So I had 12, I picked 3 of them. Do I still have 12 people to do door-to-door? Maggie, you're shaking your head no. How many would I have? I would have not 8, I would have 9. I would have 9 left. Because we take that 3, subtract it from that 12, and I'm down to 9. Well, for door-to-door, I think there was 4 people. Door-to-door sounds like 4. Yep. R equals 4, which gives me 9, choose 4. Okay, then finally, we have 5 magicians. We'll have n choose 5 this time because I already took 4 more away, and I'm picking 5 of them to be magicians. There is something special about a combination where I'm choosing 5. We'll get to that in a second. All right, this is where Nogel said order did not matter, let's use combination. 12 pick 3, that's how many combinations I can have doing a phone. 9 choose 4, that's how many I have door. Magicians, I can have 5 choose 5. Here's where we have to think back to Friday's lesson. What do we do with these 3 things? Well, we can't just add them. Adding would not work because we haven't learned anything that says just add these and that's your total. What I want to think back on is the fundamental counting principle. The fundamental counting principle says if I'm picking 1 of each of these, well, I have 12 choose 3, but I'm going to end up picking 1 of those. I can only have 1 situation where I have 3 people calling. I'm going to pick 1 of these where I have 4 people that are doing the door-to-door, and I'm going to pick 1 of these to have 5. So in each of these, I'm really just picking 1 situation that's going to work. Well, the fundamental counting theorem says if you're taking 1 of each item, you multiply, and then you'll have your total number of options. So we're actually going to multiply each of those, just like a phone number. Just like when you do 10 times 10 times 10, I'm picking 1 number, 1 number, 1 number, I multiply them. I'm taking 1 group of 3 students, 1 group of 4 students, 1 group of 5 students, and so we just need to multiply them, and then I'll have that total number. Now, this multiplication will account for me getting picked in either one of these. So that's why I'm going to go with no question mark, because we're going to start by going just combination, and then we use the fundamental counting theorem to figure out the rest. So this is just going to turn into a multiplication. I don't have a ton of room, so I'm going to kind of shortcut this a little bit. But for combination, it's going to be 12 over 12 minus 3, which would be 9 factorial, times our r, which would be 3 factorial. So once again, just for the sake of room, this is our 12 minus 3 factorial. And we're going to multiply that by, we'd have 9 factorial in the next one. I would have 9 minus 4, which is 5 factorial. Once again, that 5 comes from the fact that it's 9 minus 4. And then we'll end with that 4 factorial. And finally, we'll end with 5 factorial over 5 minus 5 factorial is 0 factorial. It's 5 factorial. That 0 came from 5 minus 5. Zero factorial is 1. 5 factorial over 5 factorial is just 1. But let's think about that. If order doesn't matter and I have 5 people standing here, how many different ways are there for me to grab 5 people if I only have 5 people standing there? 1 way. Order didn't matter, I'm just grabbing 5 people. That's why if you're using a combination, if it's a combination of you picking that same group, it's 10 choose 10, 100 times 100, it should just equal 1. Okay, we could do some more simplifying. We can say, okay, 9 factorial cancels out with 9 factorial. But what I kind of want to do is, let's go ahead and take our calculators. If you haven't found this button already, you have a factorial button in your calculator. And I'll walk you through where that is in just a second. All right, in your calculator, on your left-hand side of your calculator, about 4 buttons down, is a math button. Is it 4 buttons down? You're going to have a math button. It's 3 buttons down. Then 3 buttons down, we have a math button. I think I was counting one of those top buttons. If you go right all the way to the end, and you kind of have a PRB. Yep, PRB. So if you scroll right, you have a PRB that has a permutation, a combination button, and it has a factorial button as well. What I want you to do is go ahead and we'll type in 12 factorial divided by, in parentheses, 5 factorial, 4 factorial, 3 factorial, close parentheses, and we should get out a big number. I actually want you to type that in. I'll give you the answer you should get out. Make sure you get it. If you're not getting it, ask a question. I got out 27,720. Because this is a problem that I would let you use your calculator. Work on using our calculator. All right. Our next one. We have 50 people purchase raffle ticket. 3 winning tickets are selected at random. If first prize is $500, second prize is $100, and third prize is $50, how many different ways are the prizes awarded? Does order matter? Yes or no? Yes. Yes, it does. I care if I get first, second, or third. So order matters, which means we're using a permutation. All right, with permutation, we need to come up with our n. Our n is, we have 50 people. I am choosing 3 of them, so it should be a pretty easy formula to actually solve, even if I couldn't use a calculator. Because our permutation, which would be p of 50, pick 3 of them, is going to equal 50 factorial. But I shouldn't type 50 factorial on my calculator because it's 50 minus 3 on bottom. Well, 50 minus 3 is telling me to go, okay, that's 50 times 49 times 48 times 47 factorial, because on the bottom, 50 minus 3 is 47 factorial. Like I said, an easy way to do this in your head too is 50, choose 3 with permutation, is 50 factorial 3 places. So that'd be 50, 49, 48, you're done. If you just recognize that 3 just tells you how far to go in your factorial, it can make your life a little easier. So once again, 50, pick 3. That's how far I should go in my factorial. I should go 3 into my factorial. All right, who could give me what's 50 times 49 times 48 equals? Who came up with that? Someone had to get it before I... Theo? 600. Yep, that is correct. Easy peasy. Note, don't rely on your calculator to do factorials. I think it was Garv last week that typed in 99 factorial, and your calculator said, nope, that's too big of a number, so you'd have to know how to do it by hand. Also, you'll have to know it by hand if I tell you can't use your calculator in a section. So know how to do this elimination so that you're not stuck there not being able to do it. All right, identical objects. Super easy formula, but probably about a fourth year you get this wrong on the test because you won't go back and study it. So for me, I put a star on it, say make sure I study this, because it only shows up right here. All right, it only shows up in this one little section. We have a couple homework problems. All right, consider the word Mississippi. Consider the word Mississippi. And I'm asking you, how many different ways are there to rearrange the letters Mississippi and make new words? It sounds like a permutation because order matters. Order matters in how you spell it, so all of a sudden you're like, oh, that's a permutation problem. But then think about this. Mississippi. If I have S1 and S2 and I flip those, does that change the spelling? Has anyone ever said you misspelled the word because you put the wrong S in front of the other S? No. Well, that sounds like combination then. So this has a permutation because order matters, but a combination section because it doesn't matter which order I put the S's or the P's or the I's. So that means it's on the verge of being a permutation and a combination at the exact same time. So it needs its own formula. The formula is really kind of easy. It is just how many do I have? And then you're going to count the repetition of items and put it underneath the factorials. I think this is easier just to do than to explain. So we're just going to do it with Mississippi. We're going to see how many different arrangements exist for Mississippi. So the first thing you're going to do is you're going to come up with your N. N is your number of letters. Total number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11 letters. So once again, our N is just our total. In this case, it's our total number of letters. And then we're going to count the repetition of letters. So we're going to count the repetition of letters. So we're going to count how many times does a letter repeat. Is that what I wanted? Yeah, that'll work. Let's go repeat letters. And you're going to count even the letters that don't repeat. So I'm going to start with M. And I'm going to count how many M's there are. Well, there's one M. Then I go to the next letter, and it's got an I. Okay, how many I's do I have? I have 1, 2, 3, 4 I's. Okay, let's go to S's. How many S's do I have? I have 1, 2, 3, 4 S's. And the last letter that's in there are P's. There are 2 P's in a pod. You should double check. 1 plus 4 plus 4 plus 2 does equal 11. I counted for all the letters. Now all you have to do is take your 11 factorial. That's your n on top. And you're going to divide by all of your repeats factorial. So we're going to do 1 factorial for the m's times, I got 4 i's, so we'll do 4 factorial, times 4 factorial, times 2 factorial. Once again, to plug that in your calculator, you do 1 factorial. Make sure your denominators are in parentheses. Actually plug this in, but you should get out 34,650. Now, why this works is it's a combination of permutation and combination. A permutation would have been 11 factorial over 11 minus 11 factorial, which would have just been 0 factorial. Well, this 4, 4, and 2 get rid of all the repeat ones that would have 2 S's being in different places, or P's being in different places, or I being in different places. So this is our combination of a permutation and combination formula. And on the test, it'll be the exact same way. I'll put a word on it and say how many different ways are there to spell that word. Know this formula. I think a good thing to do in this section is have a note card or a sheet of paper that has all your formulas on it so you can just randomly study it throughout the week. It makes your life easier than having to flip through and find those formulas. So if I was you, I would get a sheet of paper, a note card, something, write them all out. That way you can keep studying them. And I would definitely have this one on there. All right, our last one. Our last one is kind of like that first one. That's kind of a combination. It was the one that Noble told us was a combination because the parts are a combination. So we have a company employs 9 male welders and 7 female welders. How many different committees are formed if a committee of 3 male welders and 2 female welders are to be chosen? So what I'm thinking about is I have a committee with 3 men, and I have a committee of 2 females. That's kind of like the door-to-door, the telephone, and the magician problem. I want you to do this problem and get an answer. And when you got it, raise your hand, and I will either say yes it is or not, or if you get stuck, ask questions. We should have basically had one where there's a combination where we have 9 males. Choose 3 of them, and we're going to multiply them by the females, which were 7. Choose 2, and that equals, was it 1764? Yeah. 1764.